Today we're doing 2.5. We're going to continue our solving of quadratics. Okay, so we've been solving this unit, right? We did solving with absolute values. Now we're solving with quadratics. Today we're going to solve by graphing, which is pretty cool to be able to see visually what's happening. And then solving using the quadratic formula. So put a slash quadratic formula. All right, for the example on the graphing, we're actually going to do one of the ones off your worksheet. So we're going to do that last because then we'll just go from there, work on the worksheet for a while. So we're going to go right to the quadratic formula, which you guys learned last year. And we sang it yesterday. And I think you learned it to Pop Goes a Weasel, right? That version of it. Just real quick, what you were solving for, you guys, is when it's a quadratic written in what we call general form, this way, ax squared plus bx plus c, and you're solving for when that equals 0. Okay, so see, there's three ways you could solve a problem like that. You could try to factor it, set each of those factors equal to 0. You could, if it was expressed as a perfect square, instead of foiling, or as a quantity squared, instead of foiling that out, you could solve it by square roots like we did here, right? This is a quadratic, and we solved it this way. This is a fast way to solve that problem, okay? Or if you get to a quadratic like this where you can't factor it, you can always use the quadratic formula. Okay, but you're solving for when it equals 0. Now, the a is always the number in front of x squared. So even if they mix the order up, the a is the number in front of x squared. Okay, the b is always the number in front of x. It's the coefficient of x is what we say. And then c is the constant. It's the number that doesn't have a variable with it. We call it the constant. Okay, so how did it go? It was x equals negative b plus or minus square root b squared minus 4ac over 2a. And I don't like that this is being recorded, but I'm going to tell you guys the Jingle Bells one, so I'm going to stand far away from this. Okay. So the Jingle Bell one goes, I like it because you say radical, so it goes x equals negative b plus or minus radical b squared minus 4ac all divided by 2a. Hey, did you with me? X equals negative b plus or minus radical b squared minus 4ac all divided by 2a. Hey. Or there's row, row, row your boat too, but after singing Pop Goes a Weasel, I can never remember how row, row, row your boat goes. Maybe sometime when we're not recording, I'll pull out the keyboard and we'll play that one for you. But, okay, so that is coming up with solutions of x that for which this quadratic equals 0. Okay, so it's those solutions where the quadratic equals 0. And the significance of that when we get to the graph is this is going to be where the y value is 0. What do we ever find when we plug in 0 for y? Do you remember what that gave us? When did we plug in 0 for y? What? It's what? And you're solving for x. You're finding on the graph, it's the x-intercepts. If you ask for the x-intercepts, it's going to be the place where it crosses the x-axis. And that's a lot of times the solution, is if I can figure out where it crosses the x-axis, I've got the answer to my problem. Okay, that's what you're solving here when you're doing the quadratic formula. Okay, you're going to have some imaginary solutions. Do you remember imaginary numbers? Can we refresh our memory on what imaginary numbers were? I'm pretty sure you did this last year in Math 2. Yeah? Yeah. Do you remember, it was the little I. Do you remember what it was defined to be? What is I? It's the square root of -1. I meant to bring my t-shirt. One of the years we did math team t-shirts where we had this. The square root of -1. Heart. Math. I love math. Okay, anyway. And the ones we did last year had the I with the slash through it. And on the back, keeping it real. No imaginary, right? So, anyway. Cool math team shirts when you're on the math team. All right, because the square root of -1 is I, what we will do when we're simplifying here, you guys, is having problems like this. The square root of -48. We're going to get to, when we use this quadratic formula, potentially negatives under our radical. This would be no real solutions. If it asked only for real solutions, it would be no real solutions. But if it asked for all solutions, then we would include what are called the complex ones, which are the imaginary solutions. Okay? This is the same as, in using radical rules, this is the same as -1, root -1 times root 48. That's how you want to think of it. Okay? And the square root of -1 becomes I. And then, so this would be I root 48. And then if there was anything that you could pull out of 48, now we just did that one in the homework, right? What was the biggest perfect square that went into 48? There's a bigger one than 4. What was it? 16. This was 16 times 3. So the square root of 16 is 4. 4 would come out. And usually we put the 4 in front of the I. So we'd say 4I root 3 is what that would all simplify to be. Okay, but just what you need to know is you're going to simplify 48 just like you would regularly, but if you have that negative under, it's going to come out as I. All right? Well, or it's equal to, I should say it equals I. Let's do another one. What would then the square root of -25 be? I want you to simplify that, and then I want you to tell the person that you're sitting next to what you got. Or if you don't have a partner, tell the people in front of you or behind you. Okay, so go ahead and tell the person next to you what you got. Okay, who thinks their partner got it right? What'd your partner get, Emily? 5I. 5I is what Emily's partner got. Anybody agree with that? Anybody get a different answer? Okay, yeah, that would be right, because the square root of the -1 here would be I, and then it's just the square root of 25, so 5I. Yeah. Okay, try one more of these. Let's do 2 plus or minus the square root of -12 all over 4. We're going to simplify this. Okay, so the first thing we'd have to do is simplify -12, the square root of -12. So I'm going to do that off to the side here. That square root of the negative would be I, right? Okay, but then we'd need to figure out then 12. What's root 12? What's the biggest perfect square factor of 12? 4. What's the square root of 4? 2. What's left under the radical? 3, right? Or if you did the factor tree, you'd get 2 times 2 times 3, pull the 2 out, leave the 3 under. Okay, so this becomes 2 plus or minus 2I root 3 all over 4, and then when we're going to reduce this, we have to pull it out of every single part of this. So what could we pull out of all of those? 2, and I'm dividing by 2, right? Dividing by 2. So what's left in this spot here? A 1, not 0. Okay, 1. 1 plus or minus, that 2 goes away. I root 3 all over 2 would be the answer. Okay? All right, going to now how we're going to use quadratic formula. The directions now are going to be to solve for x. Okay? Number 1. X squared plus 5x minus 2 equals 0. So this is set up perfectly for us. Can you tell me, because half the battle on this is figuring out what A is, what B is, what C is. All right, so tell me what A is. Sherry, what would the A be on this problem? If there's nothing there, what's understood to be there? A 1, right. A would be 1. And what would B be? 5. And what's C? -2. Now, I don't expect you to write that out every time, but just this first time we're going to do that. Okay, so it goes x equals -b would be -5, right? Plus or minus square root b squared, which would be 5 squared, minus 4 times a, which is 1, times c, which is -2, all over 2a. Okay? And then we got to clean this up. This is kind of what we were doing last night. The negative 5 will stay as negative 5, plus or minus the square root of 5 squared? What is it? 25. Okay, now here, when I multiply, it's minus originally, right? But when I multiply 4 times 1 times negative 2, which following order of operations, that's what I would need to do, this would come out to be negative 8, right? And then when I'm subtracting a negative, it becomes positive. But we're adding 8. Some people were wanting to multiply by positive 8. That's not it. You're adding 8 to it. Okay, all over 2 times 1. What is 25 plus 8? 33. So we're going to have negative 5 plus or minus root 33 all over 2. And then we'd want to see if anything could come out from 33. Looking for perfect square factors, but even just factor 33 for me. What is it? 3 and 11. Both of those are prime. We can't factor it anymore. This is your answer. These would be the two solutions. Negative 5 plus root 33 over 2 and negative 5 minus root 33 over 2 is what would cause that to be 0. Okay? On our graph, those are going to end up being the two x-intercepts. All right, try this one. X times x minus 2 equals 4. X times x minus 2 equals 4. And I kind of actually flubbed a little bit on this first one. Because we knew we were doing quadratic formula, we really should have back here attempted to factor this. But it would have been 2 factors of negative 2 that add to positive 5. There would have been no way we could have factored it. Okay? And even if we could, you can always use the quadratic formula to solve. It just takes longer than factoring, typically. So we try to factor first. Okay, can I set each of these equal to 4? Can I go x equals 4 and x minus 2 equals 4? No. I can only do that if this over here is 0, right? Can't do that. So we've typically foiled, right? So FOIL this out for me. Caleb, what would I get? Okay, so x squared minus 2x equals 4. And then what would I want to do next? Subtract the 4. So x squared minus 2x minus 4 equals 0. And again, we should attempt to factor this first. Okay? Can you think of 2 factors of negative 4 that when I added them together, they gave me negative 2? The options are 1 and 4. Can you get negative 2 out of that? And 2 and 2? No. Okay, so we can't factor this, so we're going to go to the quadratic formula. All right, Aaron, help me out. X equals, negative b is really the opposite of b. Aaron, what's b right now? Negative 2. So if I do the opposite of that, it would become positive 2, right? Okay, and then it's going to go plus or minus square root of what's going to come next? Negative 2 squared in parentheses, right? And then it goes minus 4.
1 in parentheses and negative 4.
Okay, because it goes minus 4ac all over 2 times 1, which is just going to be 2, right? Okay, let's see what we got here. So we'd have 2 plus or minus the square root of, what is negative 2 squared? 4. Okay, then I'm going to be subtracting, but then I have 4 times 1 times negative 4 is negative 16, so then it would become plus 16, right? All over 2. Okay, so we'd have 2 plus or minus root 20 all over 2. Is there a perfect square factor of 20? Can we factor that? Yeah? What's a perfect square factor that goes into 20? 4. 4 times 5, right? So I can take the square root of 4 out as 2, or you can make the factor tree, but 5 would be left under. Divided by 2. Can I simplify that anymore? Yeah? What can I do? Divide everything by 2. When I do that, I'm just left with plus or minus root 5, right? Because all those 2's cancel away. Is that right? That's not right. I made a mistake. What's my mistake? Eros, what is it? The 1. Yeah, where should the 1 be? In front of this, right? This is 2 divided by 2. 2 divided by 2 is 1, not 0. If I put nothing there, that's actually, in this case, it'd be 0 plus or minus root 5. You need the 1 there, okay? Because my answer is 1 plus root 5, 1 minus root 5. Not just positive root 5 and negative root 5. That's different. Okay, let's do another one. Number 3. 2x squared plus 3x plus 5 equals 0. All of this is positive. If I attempted to factor this, I'm just going to do it lightly above here, show you that it's not going to work. I'd have to have 2x and x, and then I'd have to have positive 1 and positive 5. And no matter where I put those, that 5 is already bigger than the 3. There's no way, with everything being positive, that I could factor this. Okay? So I'm going to go to the quadratic formula, and I'm going to sing it. Right? X equals, all right, Manny, help me out here. It goes x equals negative b. What would be negative b, or the opposite of b? Yeah, this is your b, so it would be, so I want the opposite. This is positive 3, so it would be negative 3, and then it goes plus or minus square root of, okay, the next thing is b squared. What's your b? Okay, so you're going to have b squared, and then it goes minus 4a, which is
2.
and c, which is
5.
5. And then it goes all over 2a. Did anybody not learn that little song last year? Or not? Has anybody not done quadratic before? This isn't new for anybody, right? Okay, so we'd have negative 3 plus or minus. What is 3 squared? 9. And then I'd be subtracting 4 times 2 times 5 is 40. And that doesn't become plus. Why not? All the others have become plus. Why doesn't this one? Because it's not negative, right? We don't have a double negative going on. All over 4. So we'd have negative 3 plus or minus the square root of, all right, what's 9 minus 40? Negative 31 all over 4. Okay, so that negative under the radical is going to come out as I, right? Can we factor 31? No, it's prime. So since we can't factor it, we'll have to just leave it this way. Negative 3 plus or minus I root 31 all over 4. Those would be two imaginary solutions. If we were graphing this problem, this actually means there's no real solutions. We only graph real x-intercepts. So this graph wouldn't have an x-intercept. It probably means the quadratic is either up above or down below. It doesn't cross the x-axis. All right, one more of these, and we are done. Number 4. Negative 6x plus 3x squared. Oops, got the x. Negative 6x plus 3x squared equals negative 10. Okay? So right now, this isn't even in the right order. We want to put it in descending order, and we want to get 0. Okay? I, generally speaking, like to keep my a value positive. So if I have an equal sign, I could move it to the other side if it wasn't. But in this case, it is, right? But this is the wrong order, so I'm just going to switch those. When I switch them, they're not changing signs on the equation, changing sides of the equation, so they stay the same. It's a positive 3x squared, a minus 6x. But then we need to add the 10 over. That will change because we're adding it to the other side, right? Changes signs when it goes to the other side. Okay, again, if you tried to factor this, it wouldn't work, so we're going to go right to the quadratic. All right, Elijah, can you help me with this? X equals, how would it go? What would be the first thing? Would be, the first thing is the opposite of b, yeah. Yeah, it's the opposite of b, and then it goes plus or minus the square root of, so x equals negative b plus or minus square root b squared, okay, minus 4 times, and then how would it go? 4 times a times c, yeah, all over 2, how did it go? All over 2a, yeah, 2 times 3. So again, you're going to want to have that memorized, because if you don't have it, start learning that song. Okay, so 6 plus or minus the square root of, we'd have 36, okay. Then I'd have minus 4 times 3 times 10 is what? 12 times 10, 120, right? All over 6. Okay, I need to know what 36 minus 120 is. It's gonna be negative, right? How much? 84, you guys agree? All over 6. Okay, so the negative is going to become I. The negative under that radical is going to become I. 84, any perfect square factors of 84? Yes. What goes into 84? 4 does, right? How many times? 21. And then I could factor 21 as 3 and 7, but those don't factor anymore, right? So the square root of 4 would come out as 2. So I'll have 6 plus or minus 2 would come out, and I, right? What would be left under? 21, right? We didn't pull these guys out. All over 6. Can I reduce this anymore? Yeah, I can divide everything by 2. So 6 divided by 2. And then the 2 would cancel from that, leaving just I root 21, and pull a 2 out of the 6. 3 plus or minus I root 21 all over 3.